So hello everyone, this side is Aryan here. So today I'm going to present on a topic that is precision agriculture and crop monitoring using drone. So in this presentation, we will provide an overview of a system designed to enhance agriculture practice using drone technology and sensor. It outlines how various sensor, optical, electromorphical, GPS, weather station are used to monitor environmental and soil condition. Data is collected via wireless sensor network and transmitted to a ground station where it is proceed to generate actionable insight for optimizing irrigation, pest control or crop management. This presentation also include Python codes example to simulate sensor data, manage energy consumption and implement a basic decision support system which is a DSS, and this system aims to improve agriculture efficiency and sustainability by leveraging advanced technology. So let's begin the presentation. So these all are the subtopics today we will cover through this presentation. So let's go through the sensor. So what is all about sensor in drone technology? So in drone technologies, the sensor utilize various sensor to monitor environmental and soil condition. This sensor include optimal sensor, for example, thermal, multispectral, hyperspectral, electromorphical sensor for soil nutrition and pH levels, location sensor for GPS data and weather station for meteorological data. Sensor can be ground based or embedded in UAVs. Sensor data simulation, you can simulate sensor data using Python to represent the various sensor in the system. For example, using random data generation to mimic reading from the different sensors. Here we have an example which is in the Python language. So in this code, we have a simulate sensor data, which purpose is to simulate sensor reading for temperature, for humidity, for soil moisture, and for pH. It generate random value within a typical ranges for each sensor. So like example, this function create a dictionary with a random value for each sensor mimicking real sensor data. Then we have a data acquisition device. So data is collected by the sensor and transmitted via wireless sensor network to the ground station. So the wireless sensor network operate under a mesh of point-to-point topology, ensuring continuous monitoring and data collection. So across a large agriculture field. So data acquisition and networking. For a data acquisition, you can use a Python socket library. So socket library we can use to simulate transition of a sensor data to the ground station. So here we have another example for data acquisition device. So in this example, we send the data to the ground station through the sensor data, which purpose is to send the simulate sensor data to the ground station using a network socket. So this code uses Python socket library. So Python socket library is stabilize a connection to the server, which is ground station running on a local host, that is 127.0.0.1, and transmit the sensor data over the network. Then we have a ground station. So the ground station serves as the control center where data is processed, analyzed, and stored. An incorporated decision support system that analyze the data to provide actionable insights such as optimize irrigation schedule, pest control strategies, and crop management recommendations. So ground station data processing, you could implement a simple server that receive data, process it, and perhaps store it in a database or perform some basic analysis. Here we have an example. In this Python example, we receive and process data, which receive the data sent by the sensor nodes and process it at the ground station. So explanation: this function setups a server socket to listen for incoming data. When data is received, it decoded as passed to the processed data function for processing. We have the another point, that is energy management and security. So in this architecture include energy saving mechanism to manage the power consumption of a sensor node, ensuring long term operation in the field. Security measures are also integrated to the protected data privacy and secure communication. Energy management and security. For energy management, you can simulate sensor sleep wake cycle or optimize data transmission intervals. For security, consider adding encryption to the data transmission using libraries like cryptography. Then we have a decision support system. So the decision support system could be implemented as a set of rules or machine learning models that analyze incoming data and provide recommendation. For simplicity, here is a basic rule based approach. So in this rule based approach, we have a decision support data, which purpose is to provide recommendation based on the sensor data. For an example, like for explanation, we can say a simple rule based system that make decision. For example, whether to irrigate the field or adjust soil pH based on the sensor data. Then in the end, we have a integration part or a integration example. So here how you might tie everything together into a single application. So we have a main file, which purpose is to integrate the function into a single workflow. So we have the main function simulate the entire process, generating sensor data, sending to the ground station, receiving and processing it, and making decision based on the data. So this basic starting point for creating a code-based implementation of the system architecture discussed in the presentation. Depending on the specific requirement, you could extend it with a real sensor interface, more sophisticated networking protocols, advanced data processing, and integration with cloud services. So that's all from my side. Thank you everyone for listening.